Okay, geometries, this is Chapter 1 Practice Test Review. You'll be correcting this, so if there's an issue with doing something, make sure you seek out enlightenment. Okay, and our first question. Okay, so use the diagram below for exercises 1 through 4, and this is the diagram we're talking about right here. Note that this diagram, segment AD, pierces the plane at D. So AD is going through the plane, okay, pierces the plane at D, and this dotted line is telling you it goes through it, okay, to the other end. So keep that in mind when you're going. The part of the line you can't see because the plane's there is dotted, so you have an idea that it's going through the plane. What is another name for plane F? And please keep in mind this is supposed to be a capital F there. And we are looking at this. What is another name for plane F? And plane F is here. Another name is a 3-letter name, and those 3 letters cannot be collinear. And a collinear would be all on the same line. So in this case, we name a plane with 3 non-collinear points. So we have plane, for example, GBD, or we could have plane in GDC, okay, but in this case we have to have G included, and that has to be included on this plane because this is the plane we are talking about, and these are the letters G, B, D, or I'm talking about the plane of G, D, C, 3 non-collinear letters, okay? Now, where does plane F intersect plane ADC? Now, keep in mind, plane ADC is not drawn there. If I were to draw plane ADC coming in here, plane ADC, plane ADC, okay, and remember this plane would extend out, okay, and continue through, okay, plane ADC. Where does plane F intersect plane ADC? Well, plane F and plane ADC intersect at this line. Okay, so this line is the point of intersection, and keep in mind that's CD, line CD. So I've got line CD, or I could have said line DB, or I could have said line CB. Okay, you've seen the multiple ways I could name that one line because 2 planes intersect at a line. Now in 3, name a pair of opposite rays in the diagram. Opposite rays go in opposite directions, thus the name, but they only have a point in common and they make a line. So from D, the opposite ray would be DB and DC. So a pair, DB, oops, it's not a P, DB, and it's ray DB, and ray DC. Okay, another opposite ray combo is here and here. Ray DA and ray DH. Those are opposite rays, and opposite rays in this diagram and in all diagrams, they make a line. They only have a common point and they go opposite directions. In number 4, name 3 collinear points in the diagram. Collinear. Now keep in mind, co-workers work at the same place. Okay? So when I'm looking at this idea of collinear, are 3 points, in this case, because you want 3, points that lie on the same line. So I've got a couple lines going on here. I've got this line CDB, or excuse me, I got this line CB, and I have points CDB on that line. So CDB are 3 collinear points in that diagram. They lie on the same line. I could have also said ADH. They are also points on that same, and I want to make sure that this is clear that this is not a segment or anything. They are just 3 points that are put across there. Now in this next question, we have a figure 5 through 7. Okay, so 5 through 7 is this one here. So name 2 points that are 3 units from M. Now points are letters. So 3 units from M, I've got M. 1, 2, 3, I've got letter P. And 1, 2, 3, I've got letter J. So those are the letters that I have for points. And let me move that over because it really looks like I'm putting that segment on there and I don't want that to be happening. So I have points P and point J. Okay, and I could probably emphasize this by saying point P and point J. Now, name a segment congruent to segment JO. Now, here's the thing. Congruence is based on my length, and I'm looking for segments with equal length to JO. So JO has a length. JO has a length, and we use the ruler postulate to do that. So my length from J to O, I take my endpoints and have the absolute value -3 minus 2 using the ruler postulate. That's going to give me a -5, but it's an absolute value of -5. So this is equal to 5 units. Okay, so anything with 5 units will be congruent to JO. Now, to emphasize this, if I just start here at M, 1, 2, 3, 4, 5, MR is congruent to segment JO. Okay, but I could also, looking at a green segment, say if I started there, 1, 2, 3, 4, 5, IN. Segment IN is also congruent to segment JO. I hope you're starting to see I'm looking for segments with length 5 in it, and I start at 1 point and I count on to its endpoint. So my last one, I start at 1 point and I count on to its endpoint. 1, 2, 3, 4, 5. And so our W is congruent to segment JO as well. There are multiple others. If you have any particular questions, you can talk to your respective teachers. 7, name the coordinate of the midpoint of HL. So the coordinate of the midpoint, I'm just going to clean up my diagram here, and I'm looking for the coordinate of the midpoint. So coordinate is a number of the midpoint of HL. H is here and L is here. So I'm looking for the midpoint. A midpoint is the average of the 2 values. And in this case, it's -5 plus -1 divided by 2. The midpoint is the average, so that's at -3. So -3 right here, and that's 1, 2, 1, 2 from it. So the coordinate is -3. Okay, the point would be J. Looking at problem 8, name a linear pair of angles. Remember, a linear pair is 2 angles that make a line. They look like that. So, and they have endpoints there. Boy, this is, let's get this board fixed up here because it's kind of interesting how it's behaving. Okay, so now, with that said, use the figure at the right, and remember, it's going to be like this, or it's like this, or it's like, with my midpoint, my linear pair. That's what it is. That's what I'm looking for. So 8, name a linear pair of angles. Now, there's multiple ones here, so I have a linear pair. This is a linear pair of angles. Make sure when you name an angle, the vertex is the center, and you have an angle A, F, B, and angle BFD. Now, that is a possible linear pair. Another possible linear pair. I have angle BFD and angle DFE. Okay, there are two more combinations of linear pairs in this diagram. Okay, if you have any questions about a linear pair, two angles that are adjacent supplementary, they make a straight angle, please ask your instructor. In 9, name a pair of vertical angles. Okay, so if I'm looking at vertical angles, I'm going to just get my linear pairs kind of squeaked down here, and I'm going to name a pair of vertical angles. Okay, so I got a pair of vertical angles here, and vertical angles are made by opposite rays. So this is an opposite ray, and that is as well. And this is an opposite ray. Vertical angles are made by opposite rays. So if I look this over, this is congruent to that. That's an opposite, that's vertical angles. And this is another set of vertical angles. So now, if I'm looking at this, name a pair of vertical angles. So if I have angle AFB and angle EFD, that is a vertical angle pair. Okay, another possible vertical angle pair is angle AFE and angle BFD. Okay, just to make sure that you know what they are, you got those listed. Now, name an angle adjacent to BFD. Adjacent angles share a common vertex and ray, but no space. So we're looking at angle BFD. Okay, an adjacent angle, there are two adjacent angles here. Here, that's adjacent, they share a common ray, so I could go angle AFB, okay, or I could look at angle EFD, angle EFD. Okay, name an angle adjacent to angle BFD, and that's where we're going, EFD and AFB. Those are two, but all you had to do is come up with one. Now, my last one, name an angle adjacent to BAF. So, BAF, an angle BAF is that with A is the vertex. Remember, A is the middle letter is the vertex. Okay, that's how I know where the vertex is, the middle letter. And the thing that would be adjacent to that would be this angle, FAE. So I could say angle FAE is adjacent to that. Now, moving on to our next page. Use the picture at the right for exercise 12 through 14. When we do these, you got to pay attention to what the markings mean. Okay, this means that this is 90 degrees. Okay, so I want to make sure that that's a right angle. I know that's 90. Okay, I know since that side is 90, this side is also 90. So I know that CFD and DFE are complementary angles. Okay. Now I have angle 1 is angle BFG, right? And I have the other angle to that that's supplementary to it is angle EFB. But as we do this, maybe what we ought to do is run this over and we'll just do each one as we go. So let's look at 12. Name a pair of supplementary angles. Supplementary angles is two angles that add to 180. That's supplementary. Two angles that add to 180. I don't care where they are. They got to add to 180. Okay, I could use a linear pair or not. And in this diagram, I have some choices. So if they add to 180, if they're 90 apiece, I'm good. So I know that this angle, EFB, angle EFB plus, well, I'm just supposed to come up with a pair of supplementary angles. So I'm not going to tell you about the measurements because I already know that EFB is a right angle, it's 90. I also know that angle 1 okay, is 90 degrees as well. So those is a pair of supplementary angles. There are multiple other ones, okay? I could go with this one and this one, because they don't have to be adjacent. So I could also say that angle EFB and angle EFC or CFE is also a supplementary angle pair. So make sure you recognize that they just got to add up to 180 in their measurement. Name a pair of complementary angles. Okay, I'm going to get this stuff out of my way here because I'm kind of using some space, but I'm going to make them shrink down a little bit so I can hopefully clear up the other questions that may be arising from this next question. So we're going to pull those over, and that's supplementary, and we're going to clear up my diagram. Name a pair of complementary angles. Complementary angles, two angles that add to 90. Well, that's going to be pretty nice since this is a right angle. I know this is also 90 degrees. So right off the bat, I know angle CFD and angle DFE are complementary. Angles. Okay, now I'm going to get that bad boy shrunk down because I'm going to be using my diagram again. Now they're asking me to list two other names for angle 1. So let's look at that angle 1. And I have angle 1 is right here. Two other names for angle 1 would be angle BFG and angle GFB. Again, if you have questions during this time, you can't ask me because I'm a video, but you can ask your teacher in the room. So make sure you're doing that. Make sure you're following up on the things that you have questions on because no one else is supposed to ask your questions but you. Okay, in 15. I'm looking at things with vocabulary in it. Ray MK bisects angle LMN. And so that measure of angle LMK is x plus 12, and the measure of angle KMN is 5x minus 8. What is x and the measure of angle KMN? Now, let's draw a picture. I have angle LMN. This is just a sketch. I have no idea if this is actually the angle, but it's going to help me answer my question. I have a bisector to this, MK, Ray MK. Okay, I know that this has been cut this angle into two equal parts. Okay, the first part where LMK is x plus 12. The second part where KMN is 5x minus 8. Now I know when I read the word bisects that I am splitting the angle into two equal parts. When they're equal, I know the fact that the measure of angle LMK is equal to the measure of angle KMN. Now I can use that idea of bisector, angle bisector, and set this up. So now I'm going to subtract x from both sides. 12 is equal to 4x minus 8. I'm going to add 8, and 20 is equal to 4x. Now, x dividing by 4 is equal to 5. So I know x is 5. So they asked me to find x. I got it done. The next thing they're asking me to do, because I'm rereading my question, what is x and the measure of angle KMN? The measure of angle KMN, which up here is equal to 5x minus 8. I'm just going to pull this over because I want 5x minus 8 here. And I know x is 5, so this is 25 minus 8. After I plug in my 5 goes in there. And this is 17. Okay, so I have my two answers I was asked to find from my original question. And I'm just going to shrink these bad boys down. Okay, and be able to use that space for other stuff. Okay, now I'm just going to get rid of my underlines because I underline things during my question so you don't get confused about how to write those angle values. And we're there. Now, angle 4 and 5 in problem 16. Angle 4 and 5 are supplementary angles. So supplementary angles are a linear pair. I could go 4, I could go 5. This is a really fast way to go supplementary, but I don't have to have them that way. I could have my two original angles. Here, let me get my original angles with arrows there. I could have my original angles 4 and 5. This could be angle 4, okay? This could be angle 4 over here, and this could be angle 5, okay? And I got 5, and I got 5 over here. They do not have to be touching. They just have to come out to be 180. So I have an example of a linear pair here, and I example just two angles just out there in the world, okay? But the information that I'm finding from this problem is the measure of angle 4 plus the measure of angle 5 is equal to 180 degrees. I know that from supplementary angles. These two add up to 180. After I know that I can substitute 7x minus 20 in for 4 because that's what it's equal to. I can substitute 3x in for angle 5 and set it equal to 180. At this point, I'm in algebra land. So I've got 10x combining like terms on the same side of the equal sign. Okay, I add 20 and 10x is equal to 200 and find out that x is 20. Now, they ask me what the measure of angle 4 is. Well, in order for me to do that, the measure of angle 4, and I'm going to move my angles back here so I can use that space. Remember that supplementary could be anything. They just got to come out to be, 180 degrees. And I'm going to take the fact that the measure of angle 4 is equal to 7 times 20 minus 20. Okay, this comes out to be 140 minus 20, which equals 120. Now I'm going to check my work real quick because my 5 angle, my measure of angle 5 is equal to 3 times 20, 3x, which is 60. So 60 and 20 added together is 180. So I'm very confident that this is my answer. So I'm pleased about what I got. I'm going to group these bad boys together and shrink it down and get ready for my next problem because I got this down. Keep in mind, please, as we're going through this, I'm showing my work. I'm making sure everything makes sense as I go through, and I'm double checking it when I can. Now, in problem 17, the midpoint of segment AB is provided. So I'm giving you the midpoint, 8, 7. Okay, they give me one endpoint, 11, negative 3. Okay, that's one endpoint. I'm just going to adjust this a little bit so I got some space. Now, what are the coordinates of endpoint A? Well, this is kind of implying that this is endpoint B. I'm looking for endpoint A. Now, there's a couple ways of doing this, but I find that this is probably the fastest way for us. Now, to help with this, we're going to put a shade across. I want to know how far it is from 11 to 8. And people go, 3, Bloom, 3. But keep in mind, it's 3 units, but I am going in a negative direction. I'm going negative 3. I'm subtracting 3 from 11. So keep going in that negative direction because I've gone the midpoint. It's halfway. And I'm going to take 8 minus 3 and come up with 5. Now, I should be able to check my work. It's a midpoint. That means the average of the two endpoints, and the average of my x's, 11 plus 5, 16, divided by 2 is 8. So I've checked my work. Now I'm going to do the other side over here and say, okay, I'm going to do my y's. How did I get from negative 3 to 7? Well, if we go from negative 3 to 7, I am adding 10 on the y side. I'm going to do that. That's the first half of my trip. The second half of my trip, I'm going to add 10 more, and that'll add from 7 to 10. That's 17. Again, check your work. Negative 3 plus 17 is 14. Divided by 2 is 7. So that will work as well. So I have my other endpoint, A, which is 517. So I can write down, hey, A is 517 to make sure it's clear that is my answer. Now, These are important that you read carefully. And I know you're like, oh, Bloom, come on, I can read. Number one test mistakes are when people rush. So always read the question, answer the question, then reread it. So I was given in this problem 17 the midpoint of AB, which is 8, 7. One endpoint, 11, -3. What are the coordinates of the other endpoint? Got it. 18. Find the coordinates of the midpoint of the segment whose endpoints are located at 6, 2 and -4, 14. Remember, the midpoint of GH, segment GH, is going to be 6 plus -4, the average of the x's, and 14 plus 2, the average of the y's. Midpoint, okay, is my x sub 2 plus x sub 1 divided by 2, y sub 2 plus y sub 1 divided by 2. That's what I'm using. So when I do this, I just evaluate. So the midpoint of segment GH, okay, is going to be 1, and 16 divided by 2 is 8. So that's my midpoint of this problem. Again, I'm going to group these bad boys together. I'm going to get rid of my underlines. I do that a lot when I underline stuff, but I don't want to have that confused with that being part of the answer. I just wanted to make sure that I took some notes on what was going on so I could better answer the question. Now, what is the distance between these 2 points? I'm going to do distance formula. Again, when I have 2 letters mushed together, they have no personal space, I am saying the distance between x and y, and that's the segment distance of x and y, or the length. So again, when I do this, I'm working with the distance formula, squared plus y sub 2 minus y sub 1 quantity squared. Now, I got my x's. I've got 8 minus a -3 squared plus my y's, -5 minus a 10 squared. Now I'm looking at this and I've got my 11 squared and I've got -15 squared. Okay, so I should have 121 plus 225. Well, this is going to come out, and this is going to be 346 as I'm looking this over, and I'm double checking to make sure I'm adding stuff up right. So I've got my 346, and I grab my handy dandy calculator, okay, and I'm going to go clear this out, and I'm going to go, hey, I've got the square root, second square root of 346, and that's going to enter 18.6. Now I'm going to see, what do they want me to do? Nearest tenth. So it's 18.6 is my answer. 18.6, and that's units, okay, as I write out my answer. The next page. Okay, what is the perimeter of a hexagon? Now, danger, danger, Will Robinson. Hexagon is a 6-sided figure. Okay, 6 sides. That has 6 sides. That's how I know. With a side length of 8 centimeters. Now, we're assuming that this hexagon is a regular hexagon. All the sides are the same length. Okay, and if they weren't, I could not give you the perimeter. So we're talking about a regular hexagon. All the sides and interior angles are the same. Okay, so now I just go, hey, well, 6 times 8 is going to equal 48, and that's going to be centimeters. So that's my perimeter. Okay, now remember, a hexagon looks like this, and the assumptions I made in this problem was that they were all the same. 8, 8, 8, 8, 8, 8. Okay, ain't that great that they're all 8. Okay, so 6 times 8, 6-sided figure, times 8, the side length is 48 centimeters. Now, in 21, what is the area of a circle? Area of a circle, I have a circle, with radius of 19, okay, 19 inches to the nearest tenth. Now, remember, this is not in terms of pi, so this is inches, okay? So I'm looking at this. What is the area? Area is pi r squared. So pi 19 squared. I'm going to take that and double check. I'm looking at area of a circle with radius of 19 inches. So I'm going to grab my 19 inches, and I've got 19 raised to the 19 raised to the second power, okay, times pi, second pi. Now I know this is in terms of pi because they asked me to put it into a decimal form because they said tenths as my answer. So I got 1134.1. Okay, so this is going to be 1134.1, and it's inches squared. Okay, I've got to make sure I double check I've got inches, and it's area. I'm just double checking everything. That's why it's squared, because it's area. So that's my answer there. Okay, now our next problem, what is the circumference? Now circumference and area are dangerous problems because it's the same things, at least it looks like it, because circumference is 2 pi r. We got a 2, we got a pi, we got an r. Circumference, the 2 is on the main line. Okay, or I could say diameter times pi. These are my two possible equations for this, but they're asking me for circumference of a circle with diameter, and a diameter is a chord that goes through the center of the circle, and that is 20 centimeters. Okay, so when I do this, I'm going to pick out the circumference is equal diameter times pi, and diameter is 20, and I've got 20 pi. I'm putting in my calculator, so I'm going to take 20 pi, 20 times second pi, and I'm going to get 62.8, and that is my final answer, 62.8 centimeters. And remember, this is just to the first power. It's not squared because it is circumference. Problem 23. How is naming a ray different from the line? Okay. The naming of a ray is different from a line because a ray has an initial point and it goes through B. So this is ray AB with initial point A going through point B. Okay. Now, if I'm going to name a line, how is naming a ray different from a line? My naming of a line, my line AB, my line AB, okay, the lines will go on in both directions forever, okay, my arrows go on in both directions forever. Okay, so the ray starts at A and goes through B and on through B forever, but it doesn't go beyond point A in my ray. In my line AB, my arrows go on in both directions, not it both directions, in both directions forever. Now our next one. Name the shaded plane. Okay, this shaded plane. A plane is named by 3 points. And I go plane, F, B, C. Why do I write plane in front of it? Remember, 3 points define a angle. 3 points define a plane. 3 points define a triangle. So we have to be able to discern which is which. So I'm saying the name the plane, and that's plane FBC. I could also go on plane BCG, could have gone plane GCF, okay? So combinations of those 4, but 3 letters is good enough to name a plane. In 25, what is the intersection of plane AED? I've got AED, sorry, I'm going the wrong way. Plane A, E, and D, so this plane. Okay, that's my first plane. AED is my blue. And ABF. ABF. That's my green. I kind of gave you the hint of the intersection. The intersection is line AE. So line AE is the intersection of those 2 planes. What is the intersection of DH and GH? So I'm going to get rid of that and look at DH. And I'm talking about segment DH and segment GH. Now, here's the thing. This is a great one without a picture. With the picture, you can see it was like right there. It's point H, Mr. Bloom. I can see that. Point H. But I want you to realize that sometimes on tests, we will make the problem harder by covering up the picture. So in this case, what is the intersection of DH and GH? It's the overlapping letter in the two segments. So it's point H. So there's two ways of looking at that to discern your answer. All right, that's 26. All right. Now, the day two, I want you to be able to do these, and this is something you should be very, very successful with. The day two review questions. Angle ABC and angle CBF are a linear pair. Linear pair, adjacent supplementary angles. Okay, that's a linear pair. ABC, so I got A, B, C, and CBF. And ABC is 5x minus 3. CBF is 2x plus 8. I know that these added together equal 180. So now I combine like terms. Subtract 5 from both sides, and I got 7x equals 175. Dividing by 7, x is 25. So I know x is 25. In order for me to find the remaining values, I just plop them in. So I know 25 goes in there. 25, so this is 75. Excuse me, not 75. It's 125. 125 minus 3, and that's going to give me 122. And this is 2 times 25 plus 8. That's going to be giving me 58. And I got to make sure that they add up to 180 to make sure I'm right. And it does. So life is good. Next, okay, x is the midpoint of yz. xy is equal to 3x. And xz is equal to 2x plus 5. Find x, find xy, and find xz. Please draw a segment that represents this question and answer it, please. Okay, we got it going on. Hopefully you turned me off and you turned me back on. I've got x is the midpoint of yz. I've got y, I've got z, I've got x is the midpoint. X is the midpoint. These are equal. Okay, ooh, they're equal. No way, Bloom, that means this and this like this, right? X, Z, Y, and they are equal. So 3x is equal to 2x plus 5. And now I subtract 2x, and I got x is equal to 5. So I know x is 5. And I can plop x is 5 back in there, and that's 15 for xy. That's 15. And I can plop 5 back in there. I know that this is 15, and it checks out. And if I wanted to be really sneaky, I'd have gone, hey, what's YZ? And that's 30. Okay. Now, the last thing. I want you to tell me what the symbol is for each one of these. Length of segment AB, line segment AB, line AB, ray with initial point A through point B, and ray with initial point B through point A. Okay, turn it off, answer the questions, turn it back on. Okay, length of segment AB is just AB. Now, a lot of times we have segment AB, and that should have been segment AB like this. Length of that, or segment AB, could have been like that. But when we're talking about, it's the length from A to B of that segment. Line segment AB, AB, over the top. Line AB, arrows on either side of your picture, AB on top. Ray with initial point A through B, initial point A through B, and ray with initial point B through A. Okay, be familiar with those. Okay, thanks for your time. I hope things are going well. If you've got questions, make sure you ask them. Have yourselves a great day.